So, this is the big topic. If you're interested in how we could move to a cleaner energy system with less carbon dioxide going into the atmosphere every year, how do we do this? Petroleum is pretty much the only game in town. We've been doing this for 100 years. So, the cool thing is, there are alternatives, and the technology is pretty much ready, and we're doing it. It's just kind of slow, but here it is. Um, First of all, petroleum is refined into gasoline and other fuels that are used for almost all of our transportation, whether it be autos, trucks, trains, ships, and even air travel. How can our global civilization make a transition from petroleum to one with minimal or no systems emissions of greenhouse gases, especially carbon dioxide and methane? So, some places like the Philippines and Nicaragua that have lots of natural gas, they run their automobiles on it. And in fact, you can buy in the United States, and you can see fleet vehicles and pickup trucks that run on it. Some municipal buses do. So it's doable. It's just that it's not. Um, the infrastructure is, first of all, it costs a lot to do it for all of us. But the other piece is natural gas is a fossil fuel. So we haven't really solved the problem if we use that. So moving down then to the next one, um, hydrogen. Now, what is hydrogen? Well, we all know about H2O, right? So if you take electricity and you are able to hive off using the hydrogens from the oxygen, you have hydrogen. Now, that's not stable, so it has to be stored in some kind of medium. It can be liquid fuel, it can be stored in solids, um, and in whatever way it's done. And then there is technologies for that. In fact, I have a fuel cell car. It's a little model car that has a solar panel on it, and the solar panel makes electricity that splits the water molecule, and then have the hydrogen. Then the hydrogen later recombines with oxygen, and that releases some of the energy that it took to split it in the first place. And voila, you have a fuel cell. It's kind of like electricity. It's a similar concept, but it's not a big battery or a motor like an electric motor in the way that we would think of an electric car, but it's similar. Um, the problem is extremely expensive, and we'd have to have this huge hydrogen infrastructure piping around everywhere, or somehow having filling stations and that were hydrogen compatible. And there is a small segment of highway in California that does this. Um, but the problem is the cars are really expensive. The cars could get cheaper if we made more of them, but to make more of them that people would buy, we'd have to have the hydrogen infrastructure. But nobody wants to build the hydrogen infrastructure because they're not sure the cars will ever be cheap enough. So you have a chicken and egg problem. Japan is making some fairly large bets on hydrogen. I don't want to count it out, but I think we have better options. The next one down is biofuels. And by the way, they're not better options. And here's why. First is photosynthesis operates with a very low power density, meaning that it takes a huge amount of farmland to put out very much fuel. Number two, humanity claims a large share of the biosphere's primary productivity already, maybe 1/5, and it would just mean more loss of biodiversity, land degradation, deforestation, clearing of the prairies wherever we did this. So we already have a very disturbed biosphere. This would make it worse. Further, number three, the economic and net energy costs are very high due to the energy required for fertilization, machinery, irrigation, and biomass conversion. An example of that is the corn ethanol system in the United States. There's almost as much, takes almost as much energy to produce a gallon of corn ethanol in terms of inputs as the corn ethanol itself has in it. It's just crazy. And there are carbon emissions associated with that. So that's not it's a very mature industry in the United States, and it's like 10% of our fuel here in Oregon, as you probably know. But it's ecologically a mess, and we're just eroding away precious topsoil. We're not making any more of that, and we're using uh, water from depleted water tables to do it too. So it doesn't really make sense. There's some talk of algae someday. 25 years ago they were talking about 25 years from then that we maybe would be there. They're still saying that where we can get it to be cost effective. There's a very high photosynthetic productivity in the water. Maybe someday we'll be able to make fuel cheaply enough to make it go. So the other thing about corn, going back to that, is that ethanol is 10% of U.S. gasoline, but occupies 40% of U.S. corn land. So you can kind of do the math on that. Is this a solution for all of our fuels? No. And as I said before, the way we grow it now, at least, it is carbon intensive because of the fuels used to make the fertilizer, to power the tractors, to process the corn into ethanol, and so on. So 1 acre of corn ethanol is a fuel versus 1 acre of solar panels to power an electric car. Which one would power a car a greater distance from 1 year of production? I'm going to come back to that idea, but there's an important point to make there. The next one is most land that could be used to grow biofuel crops could or is already used to grow food. So that means if we plant more biofuel crops, we'll have less food crops. And it's not hard to figure out how that could affect food prices. As it already has, there's a spike in corn prices about a decade in Mexico, tortilla riots and so on. It's a big problem, especially with the poor in developing countries where over half of their food budget, or half of their household budget is food. So has a lot of problems. Electric automobiles. Now this is the one that I see, and most people who are kind of close to this story see as having the greatest potential. One of the things that has happened is the cost of batteries has been falling at maybe 15% or a little more over the last decade. They're getting cheaper and cheaper and cheaper. The energy cost per mile is, you would be surprised. Let's just say you can get with a Model S, a Tesla Model S, let's see, Model 3, you can get 4 miles per kilowatt hour. A kilowatt hour is 8 cents, and where I live in West Salem, so it's not hard to do the math. If you can go 4 miles on 8 cents, what is the cost per mile? 2 cents. Now, you can tell me this, compare that one with gasoline. If you got $3 gasoline and you got 30 miles per gallon, a fairly efficient car, it wouldn't be too bad. You got 10 cents per mile. Well, so it depends on your car and so on. But if you look at a well-equipped gasoline-powered vehicle, gets 30-ish miles per gallon. Let's say that the gasoline is going to be 2 cents, or excuse me, $2. And you're getting 30 miles. That's about 7 cents a mile, 6.7 cents a mile. If you want to get close, that's still way, 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 way more money. What I'm trying to say here is that it's like having 60 cents a gallon gasoline in terms of your energy cost per mile if you're filling up at home. In other words, if you're plugging in at home. Maintenance cost on electric vehicles is very, very low. It's a reason that dealers don't like them, because dealers nowadays don't really make much money selling cars. They make money by doing the repairs, maintenance, all that stuff. That's where the money's made. But a regular vehicle, conventional vehicle, gasoline powered, has over 2,000 moving parts. An electric vehicle might have 20 some parts to it. There's just not as much to wear out or break down. Now, you do need to do tires, maybe even a little more with tires, because the electric cars with all the batteries are a little on the heavy side. But otherwise, the costs are very, very low. And the newer Model 3 technology that Tesla has, they're suggesting 400,000 miles before you need to replace the batteries. And then they can take the batteries and they'll use them in industrial electricity storage. At that point, they only have about half of their recharge capability, but still useful. So kind of a nice bonus there. Could EVs, electric vehicles, disrupt global oil markets? That's the interesting question. Now, we are just as I am talking with you about this, this is the COVID-19 spring, right? That we're all bummed about. And we saw gasoline prices fall very fast, but oil prices fell even faster. What's going to happen with that? Can't predict it, but gasoline will be cheap for quite a while. Probably half a year to year minimum, I would say, until we really get back to normal driving. And oil markets are very sensitive to supply and demand. So we may never not see $3 gasoline or $3.50 gasoline like we had. May not see that in a while. So electric is cheaper and the price is more stable. And we don't have to buy it from a foreign country like we're still buying some of our oil. Yeah, we are still a net oil importer, even though we also export oil. That's kind of a complicated thing. Another story. Anyways, so I hope this is useful for you in understanding that there is a great potential electric automobiles. But I'm gonna have you look at some videos and other stuff here a little later on. So we're not done with this yet. Thanks for your attention.